Hello students, good morning. Here I am again back with the next answer. Here the next concept we have is here regarding galvanic cell. One of the important 4 mark answer question in the iPAQ point of view from the electrochemistry concept. Okay, here the question is what are galvanic cell? Explain the working of galvanic cell with neat sketch taking Daniell cell as example. So what do you have? We have to explain what are galvanic cells, and also we have to explain how the galvanic cells are going to work by taking an example of your Daniell cell. Now let us see what is a galvanic cell is. Here I have the definition, that is a galvanic cell is an electrochemical cell that converts the chemical energy of a spontaneous redox reaction into the electrical energy. Right, clear with this definition here? What is trying to say here? Here galvanic cell is an electrochemical cell which converts the chemical energy of a redox reaction into the electrical energy. That means that it is a device, simply we can call it as a device which converts the chemical energy into the electrical energy. Okay, the conversion of chemical energy into electrical energy by a device or a cell called to as your galvanic cell. Now let us see how to construct the Daniell cell. Now what is here? To construct the Daniell cell, we are going to take the zinc rod, and this zinc rod we are going to dip it into the zinc sulfate solution, and this zinc rod is going to function as the anode. Similarly, we are going to take the copper rod, and this copper rod we are going to dip into the copper sulfate solution, and this copper is going to function as the cathode. Right, we are going to have the two half cells. One half cell is the zinc sulfate solution which contains the zinc rod which is going to act as anode. Another half cell contains the copper sulfate solution which contains the copper rod dip into it, which is going to act as your cathode. Okay, now both these electrodes are connected through the salt bridge. Okay, both the electrolytic solutions are connected through the salt bridge, means both the half cells we are going to connect it by using the salt bridge. Okay, and the rods, nothing but your zinc rod and the copper rod, we are going to connect it by means of your metallic wire. We are going to connect it by means of your metallic wire. Let us have one simple representation here. See, this is, suppose this is the one half cell and this is your other half cell. Okay, here we are going to have the zinc sulfate solution, we are going to have the ZnSO4 solution, and here we are going to take the copper sulfate solution. Here we have the zinc rod and this is your copper rod, and this both the half cells are connected by means of a salt bridge. So this is your salt bridge which is connecting the two half cells, and these two electrodes, one is your zinc electrode, other one is your copper electrode, both are connected by means of a metallic wire. Right, this is the construction, the arrangement how we are going to carry it out for a Daniell cell. Now let us see what the reactions will take place here. So at anode, zinc undergoes oxidation to form Zn+2 and releases the 2 electrons. At cathode, the copper undergoes reduction and forms the copper. So when I combine the two reactions, to overall we can write it as Zn plus Cu plus 2 gives Zn+2 plus Cu. Right, this is your overall electrochemical reaction that takes place in the Daniell cell. Now let us have the continuation to this. Here oxidation half cell is written on the left hand side and the reduction half cell is written on the right hand side. Generally we have some different notation, means the different method of writing the electrochemical reaction. So how we are going to write this reaction here? See, the reaction is written in this form. The electrochemical reactions we are going to write in this form. Generally we write the reactions as here, right? We write the chemical reactions in this form here, but in case of your electrochemical reaction we are going to use some iPAQ nomenclature. By using this we are going to represent the electrochemical reaction in this format. So in this format, what does it denotes here? That is, oxidation is written on the left hand side. That is, reaction is nothing but your oxidation reaction, and this the left hand side represents the reduction reaction. Okay, and both the metal and the ions are separated by a slash. They are going to separate by a slash, and both these half cells, that is oxidation half cell and reduction half cell, both are separated by a double slash. Here this double slash is simply called to be as your salt bridge, right? That is the points which are given here. See, oxidation half cell is written on the left hand side, that is the writing on the left hand side, and reduction half cell is written on the right hand side. Here the reduction half cell which is on your right hand side, and here metal and metal ions are separated by a slash. So metal and the metal ions both are separated by the slash, both are going to separated by the slash, and both half cells are separated by double slash, that is known as your salt bridge. Okay, here both the half cells are separated by the double slash, this is known to be as your salt bridge. Okay, so general representation of the cell is this one, right? This is how we are going to represent the electrochemical reaction. Is it clear, this one? So that is one of the important 4-mark answer question, that is regarding the galvanic cell, that is the construction and the working. Let us see it once again here. See what is here. A galvanic cell is nothing but an electrochemical cell which converts the chemical energy into the electrical energy, right? So to construct this Daniell cell, what are we going to take? We are going to take the zinc rod in the zinc sulfate solution, which is going to act as your anode, and we are going to have the copper rod dipped in the copper sulfate solution, and it is going to function as the cathode. And both are separate, both these half cells are connected by means of the salt bridge, right? We are going to connect by means of your salt bridge, and both these electrodes, anode and the cathode, are connected by means of your metallic wire, and these are the reactions which takes place at the anode and the cathode. This is your overall reaction. The same reaction we can write in the form of this representation, right? We can write it in the form of this representation. How we are going to write is, we have already learned in the points here, that is oxidation onto the left hand side, reduction onto the right hand side, metal and metal ions separated by a slash, and both the half cells are separated by the double slash which denotes the salt bridge, right? So prepare this answer, one of the important for your IP point of view, right? Thank you.